Good evening, all of you. In this session, we'll discuss about some numerical based on entropy. So this is a very beautiful problem, right? I'm taking this one. The air is flowing steadily in an insulated pipe. The pressure and temperature at two stations A and B are given in table. Establish the direction of flow of air. Take Cp is equal to this one and R is equal to this one, right? So in this question, air is flowing steadily and in an insulated pipe. Okay, this is pipe, and pipe is insulated. That means there is no heat transfer from pipe to surrounding. Okay, so this is my system and this one is surrounding. Okay, so there is no heat exchange between system and surrounding because this pipe is insulated. Okay, right. The pressure and temperature of two stations A and B are given in the table. There are two stations, station A and station B in pipe. The pressure and temperature at station A and B are given in this one. The pressure at A is 130 kilopascal and temperature is 50 degrees centigrade. Pressure at B is equal to 100 kilopascal and temperature is 30 degrees centigrade. Right? Then we have to establish the direction of flow of air. That means we have to find what is the direction of flow of air, whether from A to B or B to A. This is a very interesting problem. In this question, the Cp and R, these values are given. We have already discussed in the beginning of the second law of thermodynamics why second law is introduced and what is the drawback of first law of thermodynamics. As we have discussed earlier, the drawback of first law of thermodynamics is basically it only states that it converts into one form to another form. It does not give any direction regarding the process. That means heat into work. Energy will convert from one form to another form, like heat into work. But it does not give direction of process. We have already discussed in beginning, the direction of process can be found out with the concept of entropy, which is studied in second law of thermodynamics. We have already explained this statement. This is a very beautiful statement. So direction and feasibility of any process can be found out with the concept of entropy, which is part of second law of thermodynamics. In this problem, we will find the direction of flow of air with the concept of entropy. This is beauty of the entropy or second law of thermodynamics. Right? So in this problem, let us assume that air is flowing from A to B. This is our assumption. You can assume from B to A also, it does not matter. So let us assume the air is flowing from A to B. And in this condition, we will have to find del S of universe. What is the value of del S of universe? We have to check this one. Okay. We know del S of universe is greater than or equal to 0. We already explained this equation. Because our universe is insulated. Okay. Basically, this equation is del S of universe is greater than or equal to dq by t. But our universe is insulated. That's why this is equal to 0. Because this for insulated universe, this dq will be 0. Right? So this is our equation. Del S of universe greater than or equal to 0. And we know that universe consists system and surrounding. That means del of system plus the surrounding greater than or equal to 0. Right? A process is reversible. For reversible, this quantity will be 0, and for irreversible, this quantity will be greater than 0. Already we have discussed this term, okay? Just I am revising this some basic fundamental so that you can understand how this problem can be tackled, how this problem can be solved, right? So we have to find del S system and del S surrounding, and we have to check what is the value of this one. Okay? So this is already written here. Del S of universe greater than or equal to 0. This equation number 1 already have explained here. And universe consists system and surrounding. Okay. Since we know that this pipe is insulated, that means there is no heat transaction. This Q is 0. There is no any types of heat addition in the surrounding. Therefore, ds surrounding is 0 by T, because there is no any types of heat addition. So this is equal to 0. So del S surrounding will be equal to 0, because in this condition this is equal to dq by T for surrounding, and since pipe is insulated, therefore this quantity will be 0. So del S surrounding will be 0, right? So if you put the value of this equation, this value in this equation, let us put this equation number 2. In this condition, what we find? Del S system greater than or equal to 0. Okay. So now we have to check the value of del S of system, and after calculating this value, we will be able to find out in which direction the air is flowing. Whether this direction, whatever we have assumed in this process, whether this is possible or not. Okay. So we have to find the del S of system, right? Okay. We know that this TDS is equal to dH minus VdP, and dH is equal to CpdT minus VdP. So ds is equal to CpdT by T minus V by T dt. Already we have discussed this one. From after integrating, okay, this point A to B, let us point entropy at A is equal to SA, entropy at point B SP. This TA to TB, pressure at A, PA to PB. Okay, so you can find out this del S, this is equal to SB minus SA is equal to CP ln TB by TA minus V by T. This is equal to R by P. Okay, V by T is equal to R by P, and in this condition, this is equal to R ln P by PA, right? So this is the equation, right? Okay. This equation is written here. This del S system is equal to SB minus SA, because we have assumed that air is flowing from A to B. In this condition, this equation we have derived here. This one, Cp ln TB by TA minus R ln PB by PA. After putting this value Cp and R is given in question. Everything is given. We have to be careful. Temperature in Kelvin. Okay, right. After putting the value, we'll observe here this value is negative. The del S of system is negative, and we know that del S of system always either it is greater than 0 or equal to 0. It cannot be less than 0. The del S of system cannot be negative. Therefore, our assumption is wrong. So if del S of system is less than 0, and this is not possible, it will either 0 or greater than 0. It cannot equal to 0. This is not possible. Therefore, whatever our assumption, because we had assumed that air is flowing from A to B, this assumption is wrong. So air is flowing from B to A. If air will be flowing from B to A, in this condition, this del S will be SA minus SB. Okay, because we have assumed that B to A, right? SA minus SB. In this condition, you will get plus 0.0469 kilojoule per kg calorie. So, in this condition, the del is greater than 0. So, we can say that this flow is possible and the process is irreversible. This is irreversible flow. Why? This value is greater than 0 and this is greater than 0 only for irreversible process. So, in this problem, with the concept of entropy, change in entropy, we have calculated the direction of flow of air, whether A to B or B to A. So, this is the beauty of second law of thermodynamics, or you can say that this is the beauty of concept of entropy. Right? Okay, we'll meet in next session.